Hello everyone, I'm back. So we're going to do a scrutineering over voltage test. When the system hits 4.2, around 4.2 volts, it should trip out. So here we go. I think that the actual set point is for 4.18.
And I believe it hit 4.18.
Yeah, I believe the actual set point is for 4.18. We're going to reset it. Now we can do an under voltage test. System should trip out around 3.02 or so volts. And pretty close. 3.02 volts. Exactly. Okay, now we can do a temperature test.
And we should flip this to the external sensor here.
Yeah, when you do so, it's going to trip.
Right.
Okay.
All right.
Let me go ahead and pull up temperatures on the main program here.
And all of this, of course, is done through National Instruments LabVIEW.
So you can see these are the temperatures here in degrees Fahrenheit, and these are in degrees Celsius. Right now it is set to trip at 58 degrees Celsius. That will be changed to 43 because the race officials would like to see pretty much a lower set point. But let me go ahead and do that.
Alright, and the hot air gun set.
Okay, so I'm going to use a hot gun to trip the system. Where's it at now?
28, 29. Go ahead and blow it directly on there. There we are. 32, 36, 43, 48, 52, 54, 57.994.
Right where it should have tripped.
And the temperature is now lowering.
The final test is the current test. It should trip at around 46 amps going from as you're discharging the battery, and should trip at 50 amps when you're charging the battery.
I believe you mean 86 amps.
No, when you're charging the battery, you want to go 50.
Right.
When you're discharging, you're pulling from the battery, you want to go 86.
Okay, I thought you said 46.
No.
Sorry.
Where'd you put the...
It's right here. It's right here. It's got the clip already.
Cool.
So it's ready. This time hook it up in series.
Yeah.
Oh, your voltage source is. We can flip it back to normal operation.
Yeah.
And we can reset.
Okay.
Where you're still in voltages.
Okay. So, let me get my calculator out. Or do you have your calculator or something?
There's 100 turns. So 0.5 amps should trip out the system when it's charging. 0.86 amps should trip out the system when it's discharging. So I think you're...
So right now that should register 10 amps on the touch panel.
Okay. And it is indeed registering 10 amps.
And notice that it's registering negative 10 amps, which means we're discharging. Okay, so if I increase it more, when this hits about 0.86, it should trip out. Get close.
Yep, getting close. Keep going. You might want to increase the voltage. Yeah. There we go.
Yep. Now look at the multimeter. The very that was the very last current measure. It was 85. Now we reset the system. Go back to main. It says that it's at 67 amps right now. If you look at the multimeter, we're measuring around that. And the Hall effect sensor should be accurate to within about an amp. So we're apparently doing pretty good. Keep in mind this is also a $40 meter here. It's not a fluke. Okay, so now we can do the charging test. In order to do so, I need to turn on the current, and I just need to flip the leads. Okay, this will give you a negative reading. So now we should be reading around 25.5 or so amps. Or 26 amps around. Notice it's positive now, which means we're charging. Okay. So when this hits 0.5, it should trip out. Right? So, protection works, and the BMS works, all except for balancing, and hopefully we'll be able to get that done before the race.